Hello, class. This will be the recorded lecture for section 4.5. This will be the last of the sections in chapter 4 that we will do. And it involves discussion of inequalities with quadratic functions. Chapter 4 is all about quadratic functions. Again, a little bit tricky in the sense it's a little bit new than some of the other aspects of solving just equalities. So what I like to do, and what I try to do to start this, is to go back to the single variable approach of solving equations. And so hopefully this is all just a quick review, but it's a good way to get your mind around inequalities. So say like you had this equation. And you ask the question, solve for x. So first thing you do is bring the minus 2 to the other side. You have minus 2x equals 10. Divide each side by 2. Minus 2, excuse me. And you have x equals 5. Now remember, x is the horizontal variable in the Cartesian coordinate plane. And so if you graph this, here's our 0 point, right? And you go over 5. This would be minus 5. And you put a dot right there. Hopefully, nice little review, right? But what if we change the problem and it looks like this? So now we think about what do we do if we change that from equals to less than? Well, same strategy, right? Except now, instead of getting a single answer, right, a single point, we're going to get a possible answer which includes a big interval of numbers. And so good way to do this is, again, same strategy, right? Bring the minus 2 to the other side, and you would get less than 10. Again, same strategy. You want to isolate the variable x. But just to refresh your memory, when you multiply or divide by a negative number, what do we do to the inequality? We flip it, right? So this would be x is greater than minus 5. So what does that mean on our number line? So if this is minus 5, do this in red. What this means is the number line is greater than as you go to the right. So it go all the way this way. Since there's no equal sign under here, does this endpoint be included? Because if you plug in minus 5, what would you get? You would get minus 2 times minus 5 minus 2, right? And so that would be 10 minus 2 equals 8. Is 8 less than 8? No, it's less than or equal to 8. So in that aspect, you put an open circle. And so how do we do that in our interval notation? Since the endpoint is not included, it would be minus 5 all the way, and then positive infinity because you're heading to the right here. If we put an equal sign here, what ends up happening? Well, now this works. So you would close that in, all right? And then what would this be? Instead of a parentheses, it would be our bracket, minus 5 to infinity. So hopefully that's a nice little review to get you thinking about how these inequalities work. And so the next step is to add the complexity of making this a quadratic instead of a linear equation. So say like we do this. We have the equation x squared minus 4x minus 12. And say like we want to say, what is the solution set for less than or equal to 0? So when you graph this thing, remember when you graph it, this is the y value, right? This is the output. And what is y equals 0? It's the x-axis, right? So the key will be the x-intercepts. So if you think about it, less than is below that line, and greater than will be above the x-axis line. So what we're trying to do here is kind of sketch what's going on and figuring out what part of the graph is above the x-axis, and then what part is below, and then what part touches it. Again, the x-intercepts play a huge role in this. So let's kind of walk through some of these. Oh, good. Undo. All right. So let's walk through a couple of these ideas. So what do we know about this? Well, we know the A value is 1, the B value is -4, and the C value is -12. So far, so good. So what else do we know? Well, what's the x value of the vertex? Well, the x value of vertex is -b over 2a. And when we plug in, we get minus a -4 all over 2 times 1. So it looks like the x value is +2 because those two minuses on the top there, it makes that +4. 4 divided by 2 is 2. So what's the y value? Whoops. So the y value of the vertex would be 2 squared minus 4 times 2. Minus 12. Sorry about that. Okay, so what would that be? So that would be 4 minus 8 minus 12. And that looks like that would be -16. So what is our vertex? X equals 2, y equals -16. So that's our key point, right? So this would be 2, and then -16 would be way down here. So what ends up happening to this graph? Well, the A value is positive, so it's going to be a U that opens up, right? And so if I change the color and draw this in blue, without, we do know one other point, right? Here's the y-intercept. Because when x equals 0, y equals -12. So say like this point here is -12. So you would see that the graph would open up and it would look like this. So less than and equal to would be everything below the x-axis, including these 2 points, because equal to means you're on the x-axis. So this is the whole solution set. It's everything below. So basically, how do we define the solution set? The key is to find these 2 points. I told you we'd be finding intercepts a lot. How do we do that? Well, you set it equal to 0 and solve. So we have x squared minus 4x minus 12 equals 0. So we can factor this. It would be x minus 6, x plus 2. You could always use the quadratic formula too, no worries. And so what are our 2 values? -2 and +6, right? When you plug that in, you get 0 for both of them. So this value here would be 6 and 0, and this value here would be -2 and 0. So the way that you describe this is what x values that you plug into this equation that will make the equation true. Well, all these that are above the x-axis make the equation false, right? Because it will be greater than. So it's all values starting from -2 all the way up to +6. So it's all this here. And we usually indicate that in the interval format. And because there's an equal sign, the 2 endpoints are included, which is the x-axis or the x-intercepts. So the solution to this would be -2 all the way up to 6. See a little bit of strategy now? And so when you have equations like this, you want to usually set them equal to 0, or less than equal to 0, greater than or equal to 0, etc., and solve this way. And what makes that quite nice is when you set that equal to, or set it equal to some value of 0, you're always worried about the x-axis. So greater than is above the x-axis, less than 0 is below the x-axis. So let's do one more, and then we'll move on. And so like I give you this equation, x squared plus x plus 1, and you want that to be greater than 0. So first step is, I always like to jot these down. This one's quite easy. They're all 3 ones, right? So the first step, you know, a is greater than 0, so our u is going to point up. So it's nice to know where the vertex is, right? So let's calculate the vertex. The x value of the vertex is minus b over 2a. And so what would that be? Well, if you calculate that, b is 1, so that would be minus 1 over 2 times 1. And so that would be minus 1/2. And you go, ooh, a fraction. Yeah, on occasion. You notice that I try not to give you fractions too much in the homework in this chapter. But it's always nice that it does happen in the real world all the time. So what's the y value? Oh, let me do this calculation for us. For this one. So a little bit, I'll do this in fractional form. So minus 1/2 times minus 1/2 would be positive 1 over 4, right? And then you subtract 1/2, and then you add 1. And so this would be 1/4 plus 1/2. And when you add that together, you would get 3 over 4. If you hate fractions, you could always do it with your calculator, and you punch all those in, and you would get 0.75. So what's our vertex? Minus 1/2, 0.75, or 3/4. So what would that look like? Well, if this is minus 1, minus 1/2 would be in the middle. If this is plus 1, it'd be somewhere right around here, right? And so it goes up that way. And so you look at that and you say, what do I do? There's no x-intercepts. Well, if you did the quadratic formula, you would have found b squared minus 4ac would have been negative. And so you would have realized that this graph never crosses the x-axis. So what is the solution? Well, you're looking for greater than 0. And so that's all values above that. Are there any values that aren't above it? The answer is no. So it's all real numbers. So you would indicate it minus infinity to infinity. Say like I changed the problem on you and decided to do less than 0 instead of greater than 0. Well, here we have nothing below the x-axis, so that would be no solution. Sometimes they use the term empty set. I've seen in some books as well. But either case, there's no value of x that you would plug into that equation or you'd get a number that's less than 0. So that ends this first part of the recorded lectures for section 4.5.